let's look at exercise 4E. Given that sine of theta is P over Q, with theta obtuse and P and Q both positive, find expressions for cos theta and tan theta. Let's have a look at, do you know what to do with that? You would draw a right angle triangle. You're in quadrant 2. All right, do you want to have a go? So, I'll just put this here. Question 5. So I'm going to stick it over there in quadrant 2 because it would go that way. Given that, so look, we're in quadrant 2. Sine theta is positive. Look, cos theta is negative. Tan theta is going to be negative. So you just work out your values. Just make sure that you're putting negatives in front of your tan theta and your cos theta. Sine theta is P over Q. So what would you do next? Oh, no, it's not. P over Q. Sine is opposite over hypotenuse. Be careful. So now what do we do? It's not hard, girls. Okay. Two sides, right angle triangle, Pythagoras' theorem. Of course, put the right angle in there. So therefore, the shorter side, I'll just call it x, is the square root of q squared minus p squared, isn't it? Longer side minus shorter side. So this is the square root of q squared minus p squared. So therefore, what is cos theta? Cos is adjacent over hypotenuse. It's the square root of q squared minus p squared over q. And it's negative. Very good. And tan theta is also negative. So that's a negative. Tan is opposite over adjacent. It's negative p over the square root of q squared minus p squared. Now, in question 6, it's similar, but tan alpha is k. So what's your ratio? Tan means opposite over adjacent. K over 1. Same method. Same method. Where k is positive. But we have 2 quadrants. 1 and 3. So you're going to have to give answers for sine alpha, a positive and a negative. Like, what you want to do is a quadrant 1 answers and your quadrant 3 answers. In question 7, you're asked to prove this algebraic identity. So you would just expand that, add that, and show that you get this. And then they're saying if cos x is 1 minus t squared over 1 plus t squared, what would you do with that piece of information? You would draw a right angle triangle. And if x is acute, which quadrant? Quadrant 1. So you would do a right angle triangle. I have worked solutions for this. Opposite over hypotenuse, you'd work out the missing side. All right? Those are okay. What I want to do is question 8. Equals k, and theta is obtuse. All right, obtuse. How big's obtuse? 90 to 180, we're quadrant 2. So we're quadrant 2 going this way. You know what I mean if I... So let's write quadrant 2. Sine theta is positive. Don't worry about this tan theta plus 90 in a minute. Let's just do this up. Sine theta is k, which means k over 1. Because, you know, you can't draw up a right angle with one side. We need 2 with the ratio. So where do I put the k and where do I put the 1? So I go opposite over hypotenuse. I work out the other side with Pythag. I'll call this x. X is the square root of 1 squared minus k squared, which is 1 minus k squared. Square root of 1 minus k squared. Now the question is to find an expression for tan of theta plus 90 or 90 plus theta. So you've got to say to yourself, where is this 90 plus theta? Well, where is it? That's 90. There's theta. I need an expression for that. We don't do expressions for that. We do expressions for there. So 90 plus theta, so tan So that's your 90 plus theta, because that bit there is theta. This is 90 minus theta, so it's the negative tan of 90 minus theta, which is negative cot theta. Remember, every time you see 90 minus theta, it's complementary. So we want the negative cot of theta, which is the negative 1 over tan theta. It's the tan, but we want the flip of the tan in our triangle. Do you get it? So what's tan? Opposite over adjacent. So it's the negative. Look, I'm just going to go here that tan theta is k over the square root of 1 minus k squared, but that's not what you want. You don't want tan theta, you want cot, which is, so it's a good idea to put, instead of going 1 divided by that, I would just put what tan theta is on the side, and you know it's the flip of that. Was question 8. Theta equals alpha plus 1 over 4. No, A plus 1 over 4a. Look, a bit hard to draw a right angled triangle when you don't have a numerator and a denominator. So let's make this a single fraction. What's my common denominator? 4a. So multiply this by 4a over 4a. 4a squared plus 1 over 4a. Now I can draw a right angled triangle. All right, before I couldn't. Sec theta is hypotenuse over adjacent. Remember? Sec is hypotenuse, is the flip of adjacent over hypotenuse. So drawing our right angled triangle. Now also sec theta is positive. I just want to say that as well. Sec theta is positive, I think. Yes. In quadrants 1 and 4. So I'm just going to do the quadrant 1 here at the moment. Sec is, so we're not adjacent over hypotenuse, we're hypotenuse over adjacent, aren't we? So it's 4a squared plus 1 over 4a. What you might want to write here is sec theta is hypotenuse over adjacent. So this is your hypotenuse and this is your adjacent. All right, you just don't want to mess it up. Of course, the hypotenuse has to be bigger than the shorter side as well. 4a squared is definitely, plus 1 is bigger than 4a, if a is positive. So the remaining side I'll just call y. We good? So therefore, y equals the square root of 4a squared plus 1 all squared. Do you understand why I'm all squaring it? Minus, in brackets, 4a squared. It's longer side squared minus shorter side squared. So y equals the square root of, let's expand this, 16a to the power of 4 plus 2 times that, 8a squared plus 1 minus 16a squared. So y equals the square root of 16a to the 4 minus 8a squared plus 1. Really hoping that this is a perfect square as well. And I think it is, because this is 4a squared squared and this is 1 squared, and it would have a minus. Let's just try that. 4a squared minus 1 squared. Let's have a look. 16a to the 4 minus 2 times that does give me minus 8a squared. Minus 1 squared is positive 1. That's nice, because guess what this equals now? 4a squared minus 1. So now we have our right angle triangle, and this side here is 4a squared minus 1. Great. Now we can work out our other ratios. So in quadrant 1, we know that all our ratios are positive. So we want to work out sec theta plus tan theta. Now that we've got our triangles, we can do that. It's positive. This is 1 over cos theta plus tan theta. Quadrant 1, they're both positive. So from there, I've come over here. All right, here we go. 1 over cos. Well, cos, don't we have it? Sec, we already have it. So I don't need to write that. Let's write it, I don't know, should we write it? Tan is that over that. Do you want to write it separated or the same? Let's go 4a squared plus 1 over 4a. That one. Plus, what's tan a? Opposite over adjacent. 4a squared minus 1 over 4a. Are we good with that? Because sec theta is that. Tan theta. Okay, so common denominator. 4a squared plus 1 plus 4a squared minus 1. Isn't that 8a squared over 4a, which is 2a? Great. And the other one, the other result, it says show that sec theta plus tan theta is 2a or 1 on a. So the other result is in quadrant 4. So in quadrant 4, sec is positive because it's a reciprocal of ratio of cos, and tan is negative. So sec is same as what we had before, positive. 4a squared plus 1 over 4a, but the tan ratio will be negative. So it's minus all of that 4a squared minus 1 over 4a. So 4a squared plus 1, so minus 4a squared plus 1 all over 4a, because we've got a common denominator. So that will be 2 over 4a, which is 1 over 2a. And so therefore a equals, so therefore our result is as required. We've got 1 on 2a, and that the expression equals 2a as well in those different quadrants.